In this section, we're going to talk about the unique properties of water and the pH. Water molecule is made by one oxygen atom and two hydrogen atoms. The oxygen atom is linked to hydrogen atom through covalent bond. The water molecules are weakly attracted to each other through the hydrogen bond. The formation of hydrogen bond is due to slightly negatively charged oxygen atom and its attraction to slightly positively charged hydrogen atom. So hydrogen bond only exists between molecules. Then covalent bond is existing within the water molecules. Water is a very important molecule. Many living organisms depend on water. The hydrogen bond in water gives rise to unique properties that support the living systems in the water. Some molecules can be dissolved in the water. This is called water loving. Another terminology is hydrophilic. So hydrophilic describes substances that will mix well with water, such as carbohydrates. Some molecules are water-fearing. For example, some substances that will not mix well with water, such as oil. And this type of water-fearing is called hydrophobic. Hydrogen bonds that link the water molecules can absorb energy and prevent increased molecular motion. With that feature, water can moderate temperature changes within organisms and in their environment. The density of the water can be changed. When the temperature goes extremely low, the water molecule structures will change into less dense form, and this is called ice. The ice is often float on the surface of the water, form into a protection layer. Therefore, the living organisms underneath the ice can still maintain alive. Since water has both partial positive and partial negative regions, like we mentioned before, the oxygen atom is slightly negative and the hydrogen atom is slightly positive due to the uneven circulation of the electron cloud around each atom. So due to this partially charged property, water can dissolve ionic compounds such as polar molecules. The example is sodium chloride. So we all know sodium chloride, which is salt, can be easily dissolved in the water. Water is not only serving as a solvent that can dissolve some polar molecules, water can also be very sticky. What does that mean? Water molecules can interact with each other, give rise to cohesion. This is due to the attraction between the water molecules through the hydrogen bond. This cohesion property makes the water surface to form a surface tension. On the surface of a pond or lake, sometimes there are some leaves floating on top of it. And this property allows many organisms, like mosquito, to walk on the water. Since water can be partly broken into hydrogen ions and hydroxy ions, the concentration of hydrogen ions in the water determines its pH. So what is the pH? pH is the measurement of hydrogen ion concentration. We use a log scale, which is called a pH scale, to measure the acidity of a solution. This pH scale represented by negative log of hydrogen ion concentration. So if the hydrogen ion concentration is high, the pH number should be low because it's a negative relationship between the pH scale and the hydrogen ion concentration. The pH scale ranges from 0 to 14. 7 is the neutral. If the pH scale is 7, this means the concentration of hydrogen ion is equal to the concentration of hydroxy ion in that solution. If the hydrogen ion concentration is higher than the hydroxy ion concentration, the pH scale will going down below 7. Therefore, from 0 to 7, everything below 7, the solution will be acidic because they have a higher hydrogen ion concentration than the hydroxy ion concentration. On the other side, if the pH is above 7, anywhere ranges between 7 and 14, hydrogen ion concentration will be lower than the hydroxy ion concentration. Then those solutions are called alkaline or basic. So we use the pH scale to measure the acidity of a solution. Most of the living organisms, such as human, maintains a certain pH in our body. For example, the pH in human is about 7. So if the pH is too low, many molecules will not function. For example, the hemoglobin will be dissociated from oxygen if the pH is going down. Therefore, to maintain the homeostasis or stability of the pH within the living organisms, it's very important. So in our body, we have solutions called buffers. Buffer will help to resist the change of pH, can rapidly absorb the excess hydrogen ion or hydroxy ion. For examples, carbonic acid and bicarbonate anion are used in the human body to maintain a steady pH. If the hydrogen ion concentration goes up, the hydrogen ion will react with bicarbonate and form into the carbonic acid. This acid can be converted to carbon dioxide and water. Then carbon dioxide will be exhaled to the outside through our respiratory system. On the other side, if the pH is going up, become alkaline, then carbonic acid can release more hydrogen ion to change the pH back to the normal range. So we have many types of buffers in our body to help neutralize the excess concentration of hydrogen ion to maintain the pH balance. In summary, water is a very special molecule. Many living organisms depend on it. Water can form surface tension. Water can function as a solvent. Water can absorb extra heat and therefore to regulate the temperature changes. Water can change their density and form into ice to protect the living organisms in the deep level of the water. Water-based solution can vary in pH. We have solutions called buffer in our body can help minimize the changes of the pH to maintain the normal function of our body. This concludes the section of unique property of water.